So the last thing we're going to do in this section is talk about something called the intermediate value theorem, which often gets abbreviated as IVT. And I'm going to state what it says, and then we'll kind of digest what's written. So if f is continuous on a closed interval a to b, f of a is not equal to f of b, and k is any number between f of a and f of b, then there is at least one number c in this interval a to b such that f of c is equal to k. All right, so that's what the intermediate value theorem says, but let's think about this in a picture kind of format. I think it makes it easier to digest what it's saying. We have to start with a continuous function, so let me just draw a picture of a continuous function here. And then we're looking at this function between x equals a and x equals b. This function is going to be continuous in that closed interval. And then what I do is I look at, let me draw it on here, look at, here's f of a, and then here's f of b. So those two y values are not the same. And then what this theorem says is I can pick any number between those. So let's say I'm going to pick k to be right here, k. And what it says is if I go across y equals k, there's some point on this graph where I have to hit my function. So here's my c. And it says f of c is equal to k. So as long as your function is continuous, you can always do this. I do want to kind of explain why continuous is such an important fact here. And it's not true if your function is not continuous. So here I have a continuous function, so I'll label this continuous. Let's look at one that's not continuous to see why this doesn't work if your function is not continuous. So let me pick a function here that's not continuous. Okay, so let's say the start here's a, and here's b, x equals b. And then again, I can take my f of a value. So right here, here's f of a. Here's b. Plug that in. Here's f of b. And now if I take a number between those, so let's say right here's k. If I go across to my function, it does not touch my graph at all. So that's the problem. If your function's not continuous, you can have this jump or this space that prevents this line from intersecting my graph. So now that I know what the intermediate value theorem is, let's look at a problem, a classic problem. Use the intermediate value theorem to show that the polynomial function f of x is x cubed plus 2x minus 1 has a 0 in the interval 0 to 1. So what does a 0 mean? A 0 is something, 0, it means it has some input where it outputs 0. So for example, if I input in some number, it outputs 0. That's what it means to have a 0. So if you're going to use the intermediate value theorem, you must have a continuous function. So we've first got to state why this function is continuous. F of x is continuous everywhere because it is a polynomial. Polynomials are continuous everywhere. And so in particular, it's continuous on my closed interval. F of x is continuous on this interval 0 to 1. And that's what I need to use the intermediate value theorem. So now I'm going to plug in my two endpoints into my function. If I plug in 0 into my function, you'll get -1. If you plug in 1 into your function, you should get 2. So I'm looking for a number between them. In particular, 0 is between those two numbers, -1 and 2. So this would be your k value. So by the intermediate value theorem, there exists a c in the interval 0 to 1 such that f of c equals k, but k here is 0, and that's exactly what it means to have a 0. So my conclusion, therefore, f of x has a 0 in the interval 0 to 1.